All right, now we want to take a look at the math that we were discussing the last few days. We've been working on fractions, but we've been avoiding going straight to the algorithm of adding and multiplying and subtracting, dividing fractions, and just going over the routine. I want to make sure you have more of an in-depth knowledge of what a fraction is, what it looks like, and specifically equivalent fractions, because they're going to come up a lot. I also noticed when we did some of our work that we were having a lot of trouble organizing and ranking these on a number line. So we're going to hit that again and do some work there as well. So this part here was a review. If you remember, we made this chart. You all have a copy of it. It's all colored in your book. But the part of it isn't to color it, it's to understand how it works. So first you got to remember that these are all equivalent fractions in some sort. Some are not with each other, but some are. And we've got to see how this works. First off, let's start by reviewing that one whole is one big old piece. It's one thing. Anything less than 1 is a fraction. And as you can see, they might be a little bit blurry. That's a half. And these ones over here are each a third. And these ones each over here are a fourth. And if you take time to look at it, and we discussed it, 1/2, the bottom number, the numerator, is actually the number of sections it gets divided into. And thirds are in 3 sections. And fourths are in 4 sections. And you see that they're equal sections that all fit under one whole. All of these will go into or be divided into one whole. But we're not worried about one whole as much as we are fractions being equivalent with another. So what we have to understand is that some fractions, even though they are written as halves, have fractions somewhere down here that they are equivalent to. The trick is to be able to see it. Now, before we also want to make sure that you recognize that all fractions are actually decimals as well. That 1/2 is really, if you understand that that is a division symbol, this can be written 1/2, 1/2, as decimal 5. If you don't know how I got that, it is 1 divided by 2. If you punch that into your calculator, you will get decimal 5. So what we wanted to make sure before we got into visualizing these fractions is that we got all of our all of our decimal answers done. There were some that kids knew and some we had to use calculators to do. So let's go over first the ones that should be in our memory banks a little bit, ones that are common fractions that are common decimal numbers. Well, we already said this one, and we might as well put that one up there because 1 whole is just 1, but 1/2 is 0.5. We understand that this is 0.33 repeating. Some people understand that. Some people don't have that one as quickly, but that was one that came up. Similarly, 1/4, if you have 1/4 or 1/4 of $1, people understood that was 25. It's 25 cents. Now, if you didn't get it, it's no problem. You just divide 1 by 4, and you will get that answer. So if you don't know them off the top of your head, it will not take you very much time to get it. Anyhow, some of the other ones that were pretty quick to do, 1/5 was 0.2. You don't even need the 0, so 0.2 would be fine. What other one? 1/10 is decimal 1. I'll leave it as decimal 1. And then we have to start making some decisions. So the rest of these don't fit so easily, and that's where we start to use our calculator. Okay, so I just quickly went and used my calculator to get the rest of those. I'll erase this here. And this is what we did yesterday. Now, visually speaking, how you can tell that some of these are equivalent fractions without the algorithm that we're going to do. We are going to learn it, but I want you to see them, that you can visualize them as well. Let's start with the idea of 1/2. 1/2 is right here. And what I want you to do is take a look at this line right here. So really we're only looking at this section right here. And what you do is I want you to put a ruler on the line, and you will see that it goes right down through there. And if it crosses any other tile set right in the middle of a line, like right down that line using a ruler, you've found some equivalent fractions. So we see that in the quarters, it goes right through the middle. In the sixths, it goes right through the middle. In the eighths, it goes right through the middle. Also the tenths and the twelfths. So this tells us that 1/2 has quite a few other equivalent fractions. But now we've got to look, how do we say them? Well, 1/2 is not equivalent to 1/4. Those do not equal each other. What you have to see here is that there are 2 tiles that equal this 1 tile here. So it's not 1/2 equals 1/4. It is 1/2 is the same as 2 of those 1/4 tiles. So that's actually 2 quarters. In this case down here, 1/2 is equal to 3 of these 1/6 tiles. So 1/2 is equal to 3/6. And if we continue, this one here on the 8th is actually equal to 4 of those. So 1/2 is equal to 4/8, and so on while we're doing it. So that's an easy one. But we'll do a few more just to make sure you're getting the idea. This time we'll pick something, well, where's it all? Make sure we got it all out of here. We'll pick something like a third. Why don't we just go a third? So we'll use this one right here as the box we're going to compare it to. And we're going to put a ruler on the page and we're going to go down and see which lines they intersect with. And when you run a ruler, you will see that the 1/3 will intersect with the 6ths. It will intersect with the 9ths. It will intersect with the 12ths. When we go to do this, we actually have to see 1/3, if we're going to do this one, 1/3, because that's one of these tiles, is actually equal to 1/2 of those boxes. So it's equal to 2/6. And if we jump down to the 9ths, it's 1/3 up here. Bringing it down is equal to 1, 2, 3 of those. So visually, you can see that you can find equivalent fractions in this way just by looking at them. So you start to understand a sense of number. Why did I put these decimal numbers over here? Well, you can check your work. We know that 1/3 is 33, but 2/6, each sixth is 0.16. And if you were to add those together, this one would equal actually decimal 32. But you got to remember that this is a rounded off decimal place. So this is really, really close to 33. And you'll know we talk about rounding to 2 decimal places. You can check the math just by using the decimal places as well. You should be able to see it, but you can use those decimal places to see if they're the same, if they're equivalent. Okay, so that's yesterday's work. Let's take a look at what we started doing today. So if I start with the fractions 1/2, we'll go 1/4, and how about 5/8? And I want to represent those on a number line over here. We can do that. We haven't seen it much yet, but we're going to. Before we do it, however, I want to take a chance to put all of these into decimals. We should know that 1/2 is equal to decimal 5. But if we didn't know that, we would simply divide 1 divided by 2, and that'll give us that answer. Similarly, 1/4, it's a very famous one, is decimal 25. Don't despair if you don't remember that one. Simply divide the top number by the bottom number, and you'll get decimal 25. And using my calculator, 5 divided by 8 is decimal 625. We're going to do this so we can see not only fractions, but decimal numbers represented on our number line, which is actually a graph. Now, we have to go back to our integer work and understand where the numbers fall on this graph here. Is this the larger side? Is this the larger side? How does a line graph work? Where's the numbers? You have to remember that if this was a thermometer, we would have -1, -2, -3 this way, and positive numbers this way. So what this tells us is that when things are getting larger, it is always going to the right. It's in all your math notes. It's going to be in all your math textbooks. When we're representing this on a number line, going to the right is increasing. So we have to remember that as well when we're doing our number line above. If we are going to have numbers, they're going to be increasing in this direction. So this here will be 0. We're not going to do any negatives for a few days until we're good with this. But now we have to decide, how can we represent each of these fractions on our number line, because they all have different denominators. Sure, we could go and write numbers and put them on like this, but we want to represent them as fractions first. And the key is looking at the denominators and how many parts these things are made of. In this fraction, it's made of 2 parts. In this fraction, it's made of 4 parts. In this fraction, it's made of 8 parts. If you want to be able to put them all on one graph, you have to do something where it can all work. So someone today said, well, let's start with the largest one, and then at least we know we have that one done. And that was an excellent, excellent guess as to where we should start. He didn't know when I forget who it was, but whenever whoever gave that answer, they didn't know it was right. They thought, this is a good sound theory. Let's try it out. So I will agree. Let's go 8 spaces. If that's 0, 1, 2, 3, 4, 5, 6, 7, 8. We don't need that one at the end. Now, if this is a fraction and this is 0, that would make this one 1 whole. And everything in between here and here is the fraction part. And that's what we're going to start to put on over here. So if he wanted to start with 5/8, this is 5 parts of 8. So he would simply go down the number line, 1, 2, 3, 4, 5, and right here would be 5/8. I also asked him, would you mind just writing it as a decimal so people have 2 frames of reference, one as a fraction, one as a decimal. So now we have 2 left. We have 1/2 and 1/4. And we were at a little bit of a loss what to do because we have this already broken up into 8s. And if it's broken up into 8 parts, some people were having a hard time wrapping their head around how do we wrap it into, or how do we move it into 4 parts. Well, what you have to see is that this graph, well, let's start with this one here. I think that's what we would say, 1/2. What is 1/2? 1/2 is really 1/2 of 1. It's 1/2 of the distance from here to here, because that is where 1 is. And if I was to ask you, where is 1/2 of that distance, even visually, you can say that that is the halfway point between there and there. So you have to look beyond just the little ticks that are on that graph and see where else you can start to make some ideas of where half is or where a quarter is. So this here, we're going to divide it. It's at 8. So 4 would be on one side, 4 would be on another side. So 1/2 would be located right here. It's a little bit close to the other one, but we need to see that that's what will happen with your fractions. Now we kind of know we're right because this one here, decimal 5, is less than decimal 625. So far we have a good chance of those being right. If that 5 was over here somewhere, we knew we did something wrong when we graphed it. Anyhow, there's only one left, and it's 1/4. And again, when you think of this as quarters, you should know that quarters are divided into 4 parts. And if you look at this whole thing from here to here, and you want to break it up into 4 equal parts, I'm hoping that you see, well, if you break them up into little sections of 2, that breaks up your 8s into quarters. And it's just like when you're doing it here, that these are your 8s right here at this section, and they can be broken up into quarters. You have 8 pieces here, 1, 2, 3, 4, 5, 6, 7, 8, but it can be broken up again into 1, 2, 3, 4 above. And that's what we're looking at here. So we have 1/4, and we can see it here in our mind. This part in here I'm kind of doing in my head, but you can scratch it out on the paper. 1/4 is going to land right there. It is 1/4 of the whole distance from there to there, if that's 0 and that's 1. Anyhow, 1/4 is there, and 1/4 is decimal 25. That's great math. So now we've represented all of our fractions on the number line, but we got into this today, that we want to look at greater than, less than, or equal to. And when we're looking at greater than, less than, or equal to, we're going to start comparing these fractions to each other. I know this is a long video, but I got to get this said. Someone taught you people about alligators and crocodiles and stuff. And when you guess that this one has, like you say, okay, this one has a mouth, so it must be bigger, and it just goes so wrong. So many people make so many mistakes with that. So I really would ask you and beg you and tell you, don't do it. Stop thinking about alligators. What I would like you to think of is our number lines. We've done lots of number lines, and we know that as we go in the right direction, this way, it gets bigger. Our numbers from 0, 1, 2 get bigger the more we go to the right. And similarly, as we go to the left, our numbers get smaller or less than. Now, why am I showing you that? Because I want you to see right here that if you want to say that this is greater than, that is your symbol. That is the symbol for greater than. It is going in a greater than direction. And this one here, the one that's going, the arrow that's pointing less, it's getting smaller on our number line. That is the less than symbol. And you need to really work at not mixing those up, because a lot of times you do all the work right and you get the wrong sign put in there. So these arrows and this number line is a pair. You got to think of them together. You have to know that the number line goes in this direction, 0, 1, 2, 3, and it goes to the right. You have to know if something gets bigger, it goes that way, and that means greater than. And if something goes to the left on a number line, it's getting smaller, it's getting less than. So, to end this one off, we looked at these fractions, and I asked you to pick 2 fractions to talk about in relation to greater than, less than, or equal to. It doesn't matter which 2 you pick. I'm going to pick 1/4 and 1/2. Now, when I physically look at them on my number line, it's this one and this one. And I should be able to say that this one here, 1/4, is smaller than 1/2. It is further, or it's closer to 0. It's a smaller number. And if I need a backup, I can look at my decimal numbers. And we should know that 25 hundredths is less than 5 hundredths, or 50 hundredths if it was here. 25 tenths, I should say. So this is smaller than 50. Decimal 25 is smaller than that. 1/4 is less than 1/2. So we write it like this. If we wanted to pick one that was larger, let's try something like 5/8 and 1/4. So we write 5/8. We write 1/4. We would check our 2 answers. There's my 5/8. There's my 1/4. There's no reason to circle it, but I just want you to see where they are. We can see that 5/8 is closer to 1. It's larger. It is greater than, and your symbol goes there. We have nothing on this graph that shows me equal to, but that's for tomorrow. All right, ask lots of questions. Thank you.